So I've taken us to a different scene here. So we have these flying guns. Now you can see this gun spinning around, which gives it some kind of three-dimensionality to its movement, and these guns crossing each other's paths. So what I've done in the render settings, I've got almost exactly the same settings now as the scene. I've got no render elements. I'm just going to add a velocity pass. Add that. So, oops, just added it twice. Let's remove it. And so there we go. So not a lot of settings here. You can potentially clamp the velocity. You can have this ignore Z, which is on by default. I would leave that at default, and the filtering I would again leave as per the default. Now I've rendered that out. I'm just going to pause the recording and take us into Nuke to show you how you use it. So here is our render in Nuke. You can see it's very simple. They fly back and forth. Now you can see that jerkiness actually is how it is because there's no motion blur. So it does look very jerky. So the way to do that is the node is called a vector blur. I already made one before while I was practicing, so that's why it came up first. Now the vector blur has been updated in Nuke 11. It uses a GPU, which speeds it up considerably. And it also has presets. So it has a preset for V-Ray velocity. And if you are clamping it, it has to be a preset for the clamp version. The reason it's actually erroring out is because I haven't told it what UV channels to use. I want it to use the velocity channel. There we go. So by default it's set to 0. So although that does something, that doesn't do very much. I'm going to set it to 1, just so we can see a bit of motion blur going on. There we go. And I'm going to go to 100%. So we can see that when that caches, we will see them fly across the room. There they go. Look at them go. So pretty good. It's quite a nice effect. It doesn't even look too bad on the spinning gun. What you might see, and you have to get in quite close to see it, is that when they intersect, you get these points here, and that's because the velocity, it isn't sure, you know, how fast that pixel is moving. It's getting these opposite directions. They sum up to not being moving very fast. So you've got this bit that isn't motion blurred, these few pixels. Now in this particular scene, obviously you could just paint that, but if that started becoming on a more complex scene, that sort of thing could really start to mess you up, especially if the motion blur were more extreme. Let's put something silly like 5 and see what we get. So obviously this is kind of ridiculous for how fast these are moving, but it does give us some idea of what we can see. So you can see our spinning gun is just looking a bit blobby. It's not, I'm not sure how accurate that is in terms of motion blur. And our little fireflies are even more apparent. So although they're still quite small, they're quite obvious. So, and we've also got that sort of not so motion blurred bit there in the intersection. So that's that really. So if you keep it in sane values, it's not too bad, and it's very effective with something where, like our vignette, where only the camera is moving and there's not a lot of internal movement. So all these problems are really going to arise as you see, where we have intersections or tricky 3D moves, especially things moving against each other. But for our vignette, this is going to work great. So that's it. Thank you. So in this module, we've seen how to create mats using object IDs, material IDs, and multimats. We have a workflow for keeping our naming consistent. We've seen how to create cryptomats. We've seen how to create a render layer for ambient occlusion using V-Ray Dirt. And we've seen how to create and use the depth pass. And we've seen the workflow and limitations of the velocity pass. So that concludes our module.